Here's a multiple choice question on polygons. The question is, how many diagonals can a regular convex 12-sided polygon have? You are given 5 choices: 24, 54, 64, 108, or none of them. You can pause the video, answer the question, and then look into my suggestion. Well, to answer this question, we can actually derive the formula. Let us say that we have a triangle. So let's say we have a triangle. How many diagonals can triangle can have? Well, none. But if you have a quadrilateral, that is a 4-sided figure, then how many diagonals can you have? Think about it. Let me sketch a 5-sided figure, that is a pentagon. So we got 1, 2, 3, 4, and let us say this is my 5th side. Now let's try to sketch some diagonals in these figures. Triangle, you cannot draw any diagonal. All vertices are directly connected. In quadrilateral, we can draw 2 diagonals, right? In pentagon, from this vertex we can join the 2 opposite vertex. From this vertex we can join these 2. And then from this vertex we can join that, so we get that figure. So if we count the number of diagonals, so how many do we get? So as far as the diagonals are concerned, in that case we have 0 here, 1 and 1, 2 there. Then we have 1, 2, 3, 4 and 1, 5 diagonals. So do you see a pattern? Well, if you continue doing like this, you will observe a pattern, and from there we can derive a formula that if n is the number of sides, then the number of diagonals are n minus 3 times n divided by 2. So that is the number of diagonals. So if n is 3, we get 3 minus 3 as 0, so 0 diagonals. If n is 4, then we get 4 minus 3 as 1. 1 times 4 is 4. 4 divided by 2 is 2. If n is 5, then 5 minus 3 is 2. 2 times 5 is 10, divided by 2 is 5. So it works for at least these figures which I have drawn. So let's apply this formula for 12-sided figure. So in that case, be 12 minus 3 times 12 divided by 2. So that gives us 12 minus 3 is 9 times 12 divided by 2. So that is 9 times 6, which gives us 54. So B is the right option, right? So it's a very important formula which you can remember or derive if required. I hope that helps. Thank you.